Many countries across the world experience thunderstorms. During these thunderstorms, there may be frequent flashes of lightning. Over the centuries, different societies have had many different explanations for the phenomenon of lightning.
Especially with lightning, every culture has its own notion of what it is. It is embedded very deeply in so many cultures as something. And now when you come around with some scientific explanation, it becomes very difficult for somebody to shift from what he has known since birth to some explanation in science. And it is also unfortunate that it is not something that you can demonstrate easily. You don't do experiments with lightning.
The scientific explanation of lightning is that it represents a sudden, massive electrical discharge. To understand why this happens, we need to look into the world of static electricity. With the Van der Graaf generator, electrical discharge is attracted by the person's hand. A photocopier also uses static electricity to attract the ink to the paper in selected places, and in a similar way, so does an inkjet printer. Today's lesson on electrostatics takes place at Endakane High School in Ezakheni near Ladysmith in KwaZulu-Natal. The objectives of the teacher with his learners are that they should be able to explain how objects are charged, explain how a neutral object can be attracted to a charged object, explain how an electroscope works, and carry out various activities with an electroscope. The teaching strategies to be employed are group work where learners use objects and apparatus for observation of phenomena, discuss what they observe, make notes of their observations, and using worksheets for homework assignments. Teacher Edward Mbata starts by reminding the learners that electrostatics is about charges. He builds on their prior knowledge about charges.
Each and every atom has got a balanced number, or the same number of positive charges as there are negative charges, all right? So the number of positive and negative charges is balanced. But by friction or by wrapping objects, we are causing this imbalance.
With this encouragement, learners recall that unlike charges attract and like charges repel.
And between a positive and a positive, what type of force?
The repulsion.
They
repelled.
They will repel, eh?
Yes.
One of the red.
He then distributes a red rod and a black rod to each group, as well as a piece of cloth. He explains that the black rod is made of PVC and the red rod of perspex.
By wrapping it, what are you doing to the piece of rod? You are giving it a charge.
First activity involves charging the rods and using them to attract pieces of paper.
I think the key idea here is to try and group the learners, give them activities, and then question them on what they have been doing.
Can anyone give an explanation as to what happened actually?
The roller attracted the paper.
The paper was attracted. Why?
It's because we were applying a charge to the PVC.
The teacher explains that if the rod is positively charged, it will attract the electrons in the paper. As the negative charges are now nearer to the rod, the forces of attraction will predominate and the paper will be drawn to the rod. If the rod is negatively charged, the reverse will occur. In this activity, the learners place one rod on a balancing point and charge up the other rod and then bring it nearer to the first rod. The learners first try the experiment with two differently colored rods.
They enjoy touching, experimenting, you know. It's just that they need to do it more often so that it would become a procedure. They know the procedure that whenever you want to experiment, you start by predicting. Then you do the actual experiment and then you explain. Write everything that you observe, everything that you see. As you are doing, something is happening, write it down. And try and attach an explanation why it happens this way. Going around the classroom, helping the different groups. You know, it's unlike actually me doing the talking. You could see where they are struggling, then help them there and you move on to the next group.
The learners then try the same experiment with rods of the same color. After recording their observations, the learners discuss the reasons for what happens.
What happened?
Red rod and the black rod, it is attracting.
A red rod repels to the red rod.
The teacher explains that when rubbed, the red perspex rod gets a positive charge by losing electrons, while the black PVC rod gets a negative charge by gaining electrons. If two rods of the same color are used, they are similarly charged and repel each other. If they have different colors, they are oppositely charged and attract each other. Before the next activity, the teacher introduces the learners to the electroscope.
Okay, say in a charge le object esisondeza la eduzane kwalento noma ayikakabi nayo charge. And the biggest problem, well, to start with, it's with the language. It makes them not to understand the concept correctly because they hear it in another language and they have to interpret it back to their mother tongue, and I sometimes use Zulu words in some instances, so that they understand exactly what I'm looking for.
He gives them a brief introduction to how the electroscope works. He explains that as a charged object is brought closer to the metal plate, the electrons in the metal will move depending on whether they are attracted or repelled by the charge. This in turn affects the movement of the gold leaves inside the jar. The learners then start experimenting with the electroscopes. They charge both the red and the black rods and move them closer to the electroscope and observe the reaction. In both cases, the leaves of the electroscope move further apart.
We started with the black rod close to the metal plate after charging the black rod, all right? What did you see in your group?
When you apply a black rod to the metal plate, the gold leaf move apart.
And when you pulled it away, what happened?
When you pull it, it's moved back.
Any explanation for that? Try and explain it in terms of repulsion and attraction, because we are dealing with charges.
We organize activities and then try to probe them with leading questions after we have done an activity.
Ubegi black rod la metal plate. If black rod is negative.
I try to encourage them to speak their thoughts in their mother tongue, but then as much as possible use English where they can. You are chasing away the negative particles from the metal plate, so the metal plate remains slightly positive, and these gold leaves at the end there become negatively charged, both of them, because we are talking about two gold leaves. So if they are both negatively charged, they will repel. So charge your electroscopes and leave them charged as they are.
The next step is for the learners to give the electroscope a lasting charge. This they achieve by quickly touching the metal plate with a charged rod. They find that if a rod of the opposite charge to the original rod is brought close to the metal plate, the leaves move closer together.
If the black rod touches the
Again, the teacher asks the learners for their observations and explanations.
You are actually depositing the electrons from the rod onto the plate. These electrons that have come to the gold leaves will remain where they are. They won't go back.
In the third activity, the principle of induction is introduced. The learners give the electroscope a lasting charge, then touch the metal plate with a finger. The learners find that the electroscope retains no excess or unbalanced charge if the rod is moved away before the finger touches the plate. If, however, the rod remains near to the electroscope throughout the process, the learners find that the electroscope is left with a permanent charge. On further investigation, they find that this charge is opposite to the one of the rod. The learners try to explain what happens to each other in their groups.
If you take this one, the positive and the positive, it will be open. It
it will be open because the positive and positive will repair.
Once they touch it, or they touch the equipment, and they do the experiment, it keeps them thinking, why is this happening? And what happened when
Again, the teacher asked the learners to describe what they observed and then give an explanation for it.
The leaves, they become closer.
If the electroscope has the same charge as the charged object, the opposite is true.
the rod attracts the remaining electrons. Lama electrons are asaselele, they are still attracted towards the positive rod. Ingakho ama leaves, kusho ukuthi ama positive charges aseyanda manje. There are more positive charges. So the repulsion force becomes even bigger.
To reinforce the concepts that have been introduced in the lesson, the teacher sets the learners a homework assignment with relevant questions.
I would say they were cooperative and interested in the lesson from start to end. It was a long session, but no one was bored, seemingly. Unlike when we were to tell them and they were to listen.
Now we have seen the video. We are going to talk about it. And on the studio with me, I have Lolo from Protec, and I have Liz from VETS, and Abdul from VETS. The lesson is a very controversial topic on static electricity because it brings with it a lot of cultural beliefs and misconceptions in terms of lightning and other things that learners will bring into the classroom. Do you think it is a difficult topic to teach at that level?
It is difficult in a sense, but the thing is, when one wants to teach the topic, one always has to rely on theoretical aspects in order to support the observation. So it is quite difficult, but it was interesting.
I think that what we saw in the video was really an introduction to FET, electrostatics. Yes. Most of this should have been covered at senior phase.
Okay, what do you think about the whole idea of using the mother tongue in the teaching of science?
Well, I definitely think it's an important aspect of teaching science in our country. I don't think that we can expect learners to pick up difficult science concepts in a second language. And so I think it's really important, and I like the way that the teacher moved between English and the vernacular in the video.
When learners have to respond in terms of assessment, do you think they might at some stage bring in the mother tongue concept or mother tongue explanation in their answers?
I'm looking at it this way, that if they use the vernacular in order to respond to a question, and it depends what aspect they're responding on. Sometimes, using a concept label in Zulu for a particular concept, it's fine. Whether you're using the word chair in English or the word stool in Afrikaans, or whether the word is tule, I think, in Zulu, they may use sometimes the vernacular, and
I think the problem comes sometimes when there just aren't the technical words in the vernacular. And I know I have a problem with my learners in distinguishing melting and dissolving, for instance, just because the same word is used in the Zulu.
Yeah, and sometimes also like the word force. I don't think in Venda you have a word in Venda or maybe in Zulu for the word force. So what sometimes happens is for force, power, more or less the same word is used. So that can sometimes lead to misconceptions in a way.
I was looking at this video, I'm looking at this video, and if, for instance, I say, I will charge you 100 Rand, I've used the word charge, and then my next sentence will be the battery is charging, and then my third sentence will be the white bull was about to charge the red bull. So I've used the word charge, and there the teacher was talking about this charge and that charge. It still is in the English language.
Yeah. The thing is, the word charge can be used in so many different contexts.
Yes.
And I think sometimes one needs to say, well, we're using the word charge, and in a scientific context, this is what it means. So that helps in a way, I think.
And also, at some stage, also the teacher used the plastic rod. I mean, the rods, the red and the black rod. Do you want to have a comment on those? In demonstrating the charges, where he had to pick up some papers using the black rod and the red rod.
Well, I did think that they might have linked the color with the actual charge, which isn't necessary. So, of course, it's quite possible to have a red or a black Perspex rod. But I suppose it's easier when you've got rods of different colors to refer to them by the color, as long as the learners don't think the color's got something to do with the charge.
Yes. And what are your comments about the other resources that were used on this particular lesson?
Well, I mean, the electroscope, it seemed to me, or it looked like that it was actually made, so that's improvised. Yeah, that's right, and it's sort of innovative in a sense. So I felt that was good, and all the other, I mean, using a ruler, using material that's normally available in the classroom. They did most of the experiments that they could related to static electricity. So what was useful is that the teachers gave them an opportunity to do the practical, see what is happening. And then he said, and then once you observe, then try and explain your observations. I think that was useful.
Yeah, I also like the way in which he emphasized the whole idea of observe, describe, and explain what you have observed. So that, for me, that was very important. Towards the end, the teacher gave the learners the assignment to do. What is the value of giving learners assignments after doing practical work?
The way of making a follow-up where the learners are understanding, a way of assessing what has been taking place in class, whether the learners again can do their work independently without the supervision of the teacher at home.
Yes, I think with moving to OBE methodologies, we've put a big emphasis on group work, but we mustn't lose the fact that we do need to get learners to do some individual work.
Yes, looking at the number of learners in the classroom, and learners have been given some assignments to do you think the teacher will be able to do a follow-up and actually look at all the assignments that learners have submitted?
I think that's why he was stressing that it's easy to work with groups. You look at one group, make corrections, help them when they need help. I think that is how he's making the marking, because you just can't do it individually.
But in terms of doing some sort of assessment, I think it's also important for teachers to realize that they don't have to mark everything. So if the learners had done that assignment, the teacher could have marked just one part of it.
Any other comment about the lesson as a whole, the overall?
I like the way the teacher followed up on the questions. He asked a question and had a response from the learner, and then asked a question following on that. But that was really good.
I would also, I think the teacher also, what was useful that he started with the model of the atom. And he said, well, the atoms are neutral, they have the same number of protons as well as electrons. That was useful. But perhaps maybe when the experiments were done, there needed to be some linkage with that model. When it's rubbing the PVC rod with the material there, saying, okay, this is maybe positively charged, Now let's go to our model. Why do you think it's positively charged? You know, just linking that model a bit with the experiment, I think may be useful, because otherwise they may just think that model is detached from what they're observing. So.
And it's important to indicate that it was the electrons that were moving in every case. One thought that I had when I watched the video was that this lesson was obviously quite long and had taken a lot of time. And at grade 12 level, teachers are really pressed for time to complete the work. And it did seem to me that they were spending an awful lot of time on this section of work, which is not exactly, it's not examinable work.
Yeah. No, I personally enjoyed the lesson, and I actually enjoyed the way in which the learners were relaxed, because they were allowed to discuss using their mother tongue, and they were touching things, and they were sort of very relaxed. So I personally enjoyed the lesson. Thank you very much for your participation, and that is all we have for today. Thank you to all of you viewers at home.